Hi everyone, welcome back to my channel. Our lesson today is about circular motion. Firstly, we will differentiate between period and frequency, and we will learn how to determine each of them. Then we will describe the characteristics of an object moving in a circle. Then we will learn how to determine the magnitude and direction of the tangential velocity and the centripetal acceleration for an object in circular motion. And finally, we will solve dynamics problems involving uniform circular motion and non-uniform circular motion. Now, what is the period and what is the frequency of an object moving in circular motion? The period is the time the object needs to complete one cycle. So it is the time needed to complete one cycle. The frequency is the number of cycles per second. The period is measured in seconds because it's time, that's why it is denoted by T, but capital T because it's for one complete cycle. And the frequency is measured in hertz, which is equivalent to 1 over second. Like when I say that the frequency of an object is 3 hertz, it means that the object completes 3 cycles each second. Now, the car here needs 6 seconds to complete the cycle. This is 1, 2, 3, 4, 5, and 6. So the period of its motion is 6 seconds because it needs 6 seconds to complete the cycle. Now, what about the frequency? The frequency is the number of cycles in 1 second. This car completes 1/6 of a cycle in 1 second. So in 1 second, it completes 1/6 of a cycle. The period and the frequency are inverse of each other. The period is the total time over the number of cycles, while the frequency is the number of cycles over the total time. The period could be calculated using this formula. The period is 1 over the frequency, and the frequency is 1 over the period. An object completes 20 revolutions or cycles in 10 seconds. Determine the period and frequency of this motion. The period is the time, which is 10 seconds, over the number of cycles or revolutions, which is 20, and this is 1/2 seconds. The frequency is the number of cycles in each second. So it is 20 over 10 or 2 hertz. We could calculate the frequency using the other formula. After calculating the period, the frequency is 1 over the period, which is 1 over half, and that's 2 hertz again. Now we need to study the kinematics of the circular motion. Now look at this picture. The boy here is playing with the yo-yo. If the string breaks, does the yo-yo continue its path in a circle, or it goes in a straight path that is a tangent to the motion? Try this at home. Actually, it goes in a straight line because the direction of the velocity at this point is at the tangent of the motion of the yo-yo. So for any object moving in a circular path, the velocity at any point is a tangent to the circular path of that object. Let's say this is V1, this is V2, this is V3, V4, V5, For a uniform circular motion, the speed of the object stays the same. And remember the difference between speed and velocity. The speed is the magnitude of the velocity. The velocity is the speed with a given direction. So the speed is the same for uniform circular motion, but the velocity changes because the direction is changing continuously. Okay, for an object moving in a straight line, what causes this object to bend and move in a circular path? This is caused by a force perpendicular to the direction of motion, so the object will move in a circular path. Also here, for V2, there should be a perpendicular force to bend the motion of this object. At this point, it is also perpendicular. It's along the radius of this circle, and as we know, the tangent and the radius are perpendicular to each other. At this point, this is the force. At this point, this is the force as well. So always the direction of the force is toward the center. That's why it's called centripetal force, or FC. According to Newton's second law, the net force is equal to the mass times the acceleration. And here also it is the centripetal acceleration, because the direction of the acceleration is same as the direction of the force, and it's also toward the center of the circular path. Let's do this practice now. We need to apply a force on this ball to make it move along this dashed blue line. The velocity is at the tangent of this circle, so the force should be perpendicular to this tangent. It makes a 90 degrees angle with the velocity. This is almost 90 degrees. So the object bends its direction and moves in a circular path. I will put the link for you in the description box so you can practice this. Now, to calculate the magnitude of the average speed of any object in a circular path, we use this formula. V equals 2 pi r over t. Actually, this is not a new formula. Let's break it down. V is the speed, because it's the magnitude of the velocity. 2 pi r is the circumference of the circle. So this is the distance traveled by the object. The t here, the period, is the time needed to complete the cycle. So it is distance over time. This is the formula that we know for calculating the speed. Now the acceleration is equal to v squared, the velocity that we calculate using this formula, over r, and r is the radius of the circular path. While the radius is in meters, the time is in seconds. The velocity is in meters per second, and the acceleration is in meter per second squared. If you are standing here and your friend is standing here, to complete one cycle at the same time, you need different speeds, because the radius of your friend is different from your radius. If your speed is 5.3 meters per second, your friend's speed will be 2.65. Let's decrease your speed. If your speed is about 4, your friend's speed is about 2. So the minimum speed needed for an object to go in a circular path and complete the cycle depends on the distance from the center of that circular path. As we discussed before, the speed for an object in a circular motion is equal to 2 pi r over t. The acceleration is the centripetal acceleration, is v squared over r. And the force, the centripetal force according to Newton's second law, is equal to the mass times the acceleration, which is the centripetal acceleration here in circular motion. Let's apply this formula on some examples. A car moving at 10 meters per second, this is v, 10 meters per second, completes a turn with a radius of 20 meters, this is r, 20 meters. Determine the minimum coefficient of friction. This is mu, if you remember. We studied that in the chapter of dynamics in the previous videos. Between the tires and the road that will allow the car to complete the turn without skidding. Now to find mu, we need to calculate the force of friction. To be able to apply this formula, we need firstly to construct the free body diagram of this car. If this car is moving in a circular path, the friction is the force that causes the car to move in a circular path. That's why it's somehow hard to drive your car when the road is smooth. So this is the force of friction. It is toward the center. This is v, the tangent, and the acceleration is calculated by v squared over r. Now, Fc is equal to m times the acceleration, which is v squared over r. The centripetal force here is the force of friction. So, the force of friction is equal to the mass times v squared over r. The friction force is calculated using this formula, mu times Fn, or the normal force. So this is mu times Fn. The mass is unknown. V squared is 10 squared, it's given, which is 100, over the radius of the path, which is 20 meters. Now the forces on the car in the vertical direction are Fn up and Fg down. These are the forces on the car. The friction is toward the center, if this is the roundabout. Fn is up and Fg is down. So Fn and Fg are equal because the car is not moving in the vertical direction. Sigma f of y, or of the vertical direction, is 0. Then Fn equals Fg. Fn is the mass of the car times g, which is 10 meters per second squared. So mu times 10m is equal to m times 100 over 20 is 5. These two cancel out. Mu is equal to 5 over 10, which is 1 over 2, or 0.5. As you know, mu is unitless and it should be less than 1. So if you get an answer greater than 1, then you did something wrong in the calculations. Then this is the minimum coefficient of friction between the tires and the road that will allow the car to complete the turn without skidding. This is another example. A 2 kilogram mass is attached to the end of a 1 meter long string. When the apparatus is swung in a vertical circle, the mass reaches a speed of 10 meters per second at the bottom of the swing. Determine the tension in the string at the bottom of the swing. We need to find the tension. Then we need to find the minimum speed at the top, v at the top, that allows the mass to make one complete cycle. Now let's go back and summarize the information given in the question. A 2 kilogram mass, this is m, the mass, 2 kilograms, is attached to the end of 1 meter long string because the mass is moving in a circle. The length of the string is the radius of this circle. the mass reaches a speed of 10 meters per second at the bottom. So V is equal to 10 meters per second. This is B at the bottom. Determine the tension in the string. The first step we do always in the questions of dynamics is to construct the free body diagram. We have Fg down, the force of gravity or the weight of the object, and we have the tension up because of the string. These are the two only forces affecting this mass, neglecting air resistance. Fc equals mac. Fc is the sum of the centripetal forces, the forces toward the center minus the forces outward. That's T minus Fg equals m 2 times AC, and AC is V squared over R as we calculated before. The tension is the unknown minus Fg. Fg is the mass times the acceleration of gravity. It is the mass times g, 2 times 10, and this is 20 newtons. So this is T minus 20 equals 2 times V squared is 100, it's 10 squared, over the radius, which is 1. T minus 20 equals 200. So the tension is 220 newtons. B. Determine the minimum speed at the top of the loop that allows the mass to complete one cycle. If the car is moving clockwise, this is V at the top. Of course, V at the top is less than V at the bottom. Fg is down, and the tension is down as well along the string. So here the centripetal force is the sum of these two forces. Again, Fc equals mac. Fc is the tension plus Fg, and this is equal to the mass 2 times V squared over R. This is V at the top, the unknown. T is unknown plus Fg is the mass times 10, again it is 20, and this is equal to 2 times V at the top squared over 1. Now at the top, to find the minimum speed, we assume that the tension is the least. It's a very small value, so we can neglect the tension at the top. To find the minimum speed, we consider the tension as 0. 20 equals 2 Vt squared. 2 over 1 is 2. Now divide over 2 over 2. Vt squared equals 10. So Vt equals square root of 10. This is a multiple choice question. A 30 kilogram child, this is the mass, is sitting 2 meters from the center of a merry-go-round. So this is the radius. This is the cart. The radius is 2 meters. It's the distance from the cart to the center of the circle. The coefficients of static and kinetic friction between the child and the surface are 0.8 and 0.6. 0.8 is the coefficient of static friction, and 0.6 is the coefficient of kinetic friction. Determine the maximum speed of the merry-go-round before the child begins to slip. When the child is still at rest, or at the time it starts to move, we use the static friction. Now let's construct the free body diagram. We have the force of friction toward the center. We have Fg down and Fn up, the normal force. Because the child will move in a horizontal circle, Fn and Fg are not counted in the centripetal forces. Fc equals mac. Fc is the friction force. This is 30. And AC is V squared over R. The friction force is equal to mu s because it is the static friction at the time the child starts to move, times Fn, and this is equal to 30 times v squared, the unknown, over the radius, which is 2. Fg equals 30 times 10, or 300 newtons. Then Fn is same as Fg, which is 300 again. Mu s is 0.8. Let's write it as a decimal number. That simplifies the calculations. 300, and this is equal to 30 over 2 times v squared. Let's cancel the 0 with the 0 here, the 3 with the 30, and this gives 10. Then we cancel out the 10 and the 10. 8 is equal to v squared over 2. 16 is equal to v squared if you do the cross multiplication. Then v is equal to square root of 16, or 4 meters per second. So let's summarize what we studied today. Firstly, we learned the difference between the period and the frequency of circular motion. Then we learned how to find the speed, the tangential speed, and the acceleration. After that, we learned how to apply dynamics on circular motion to calculate different forces. And we learned the difference between uniform and non-uniform circular motion. That's all for today. In the next video, we will study mechanical energy. Thanks for watching.